Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 21, Chemical Kinetics Part 3. Here are our objectives for today's video. Pause here. So integrated rate laws, there's also differentiated rate laws, but we're not really going to talk about them, are just mathematical equations that we can relate concentration, time, and the rate constant to one another. We're also only going to look at these for zeroth, first, and second order. They, in theory, could exist for higher orders, but we're not really going to look at them too much. These equations don't need to be memorized. They are on the equation sheet that I gave you. That being said, they're not labeled whether they're first, second, or zeroth on there. So just take a look at that. And we're going to apply these equations in today's video. Pause here. You don't need to draw the picture. Right, so I've got three different graphs, and I'm being asked to determine if this is first, second, or zeroth order. So the way that I do that is I look at my three graphs and I figure out which one of these is linear. And I'm seeing that natural log of absorbance versus time is linear. If I look at my integrated rate laws, it's only the first order that I'm seeing natural log versus time as being an expression. So I know that this reaction is first order because the graph of natural log of absorbance, and keep in mind that absorbance is directly related to concentration. So because the graph of natural log versus time is linear, I know that it is first order. If it was concentration versus time, or in this case absorbance, I would know that it was zeroth order. And if it was 1 over concentration versus time, I would know that it was second order. Pause here. So half-life is just the time required for the concentration to be cut in half. And that time will depend on the order of the reaction and other factors as well. We're going to just use the notation T with the subscript 1/2 to discuss half-life. Pause here. Right, so you don't actually need half-life for this. We'll talk more about half-life in class, actually. But what I do need to realize is that this is a first-order reaction. Therefore, I'm going to be using my first-order integrated rate law. Okay, so I am looking for time by initial concentration is equal to 1.00 molar. And my final concentration is equal to 0.500 molar. So now all I have to do is take this expression here and plug in. And that is 1.7 seconds. There's actually another way that I could have solved this, and I would have gotten the same answer that I'm planning on showing you in class, but I think that based off of the information in the video, this was the easiest way to solve it. Okay, and here are the practice problems for today's video. Thank you very much for watching, and have a great night.